Hi, welcome to the Space Vehicle Mock-Up Facility here at the NASA Johnson Space Center. Today I am hanging out at the Orion Crew Module Capsule mock-up with NASA astronaut Lee Morin. Lee, welcome and thank you for coming out today.
Thank you, pleasure to be here.
So real quick, can you tell me about Orion?
Orion is a man-capable spacecraft that is able to go far beyond the low Earth orbit to allow us to explore deep space, including the Moon, Mars, or asteroids.
So real quick also, just tell me briefly what your title is in relation to this. We know you're an astronaut, but what is your business here with Orion?
Currently, I lead the Crew Interface Rapid Prototyping Lab, or RPL, where we're building the prototypes for the displays and controls for Orion. We build the prototype hardware, and we also are building the software for the cockpit displays and controls. And that software next year will be taken by Lockheed Martin and turned into the flight software that the astronauts will use to fly to Mars.
Wow, that's exciting. And so what milestones are we looking at? I understand there's going to be an exploration flight test.
There is, the EFT-1 Exploration Flight Test 1. It will be about a year from now,
okay.
And that will take the Orion capsule over 3,000 miles above the Earth, so it can return very fast and test the heat shield.
Okay. So 3,000 miles above, that's further than we've ever been since what, Apollo?
That's further than a manned spacecraft has been since the Apollo era in the early 70s.
Okay, and this is not going to be manned, this
The EFT-1 will not be a manned. It's an initial test, so that's not manned, but it's a man-capable vehicle, and we will be going on to the EM-1 and EM-2 missions. The EM-2 mission will be the first manned mission.
Okay, and I understand we have actually had some Ascent Simulations with this cockpit control that you've been working on now with astronauts. Can you tell me a little about that?
We have this year, we've done our first integrated simulation where we'll have teams of astronauts, commanders and flight engineers working the controls and going through the ascent procedures, also testing the emergency abort procedures. And so that was done for the first time this year, and the first time we've used this medium fidelity mock-up. And that's a big milestone for us.
Wow, exciting. So we're ready. I'm ready to get inside there and take a look at what you guys have been doing. Let's take a look. Okay, Lee, so now we're inside the crew module mock-up. And right now, tell me, what are we looking at here? This is the cockpit.
Right, this is the console of the Orion cockpit. And basically the view you have now is the view that the astronauts who are going to be leaving these near-Earth orbit and going out to Mars or the Moon or an asteroid, this is the view of how their mission starts. And what we have is 3 consoles, and these are the screens that have all of the electronic procedures, which you see here, and they also have all of the flight instruments and system instruments that you can see here, and this is how they'll control the vehicle. As you go uphill, you can follow your trajectory on these flight instruments, and so that would be the prime job of the commander, which is the person sitting in my seat. And then the flight engineer sitting in your seat would be primarily looking at the various systems to make sure that the vehicle is performing properly and that there are no malfunctions.
Okay, so I've seen the cockpit inside the space shuttle, and this is quite a bit more condensed. Tell me, what are some of the improvements that you guys have worked on for this particular?
Right, the crew in the shuttle had over 2,000 switches around them. Here we just have about 60. And everything, all those other switches have been moved onto the glass. So this is a glass cockpit, which means that you use a lot more computer screens. In addition, the shuttle had several hundred pounds of books that the crew used to tell them what their procedures were. Now all of these books are here on the glass in the form of electronic procedures, or EPROCs. And these EPROCs actually will walk the crew through the things they need to do to operate the vehicle or to respond to an emergency or a malfunction.
Okay, so we've been able to eliminate all of that. How many pounds of paperwork?
It was about 250 pounds of office supplies and paper materials, and now almost all of that is on the glass. You still need one small book to tell you how to reboot the computers if you need to. But other than that, everything will be on the glass, like as you see right here.
And you mentioned on the glass. This is not touch.
Right, these are not touch screens. What we use is we have edge buttons, and so these edge buttons allow you to navigate between different displays. Buttons on the bottom allow you to bring up different screens. The buttons along the sides allow you to interact with that specific display. So, for example, on the over there you can see those edge keys. It says nav source. So if you push that, it would change the navigational source.
And so explain to me why you guys decided not to go with the touchscreen.
Right, well, the decision was made not to go with touchscreen. We were concerned about two things. One is something hitting a touchscreen, floating in space, and making an inadvertent action that you wouldn't want. And the other is that touchscreens really require your fingers to touch the screen, and in spacesuit gloves, that becomes a problem.
So tell me, what goes into designing this type of interface? I mean, what was, just kind of go through the process.
What happens is that you'd have the system engineers would say, well, this is what we're going to have, this is how many tanks and valves and switches we need for a particular system, maybe the propulsion system, and this is how the system works. So we would sit down with crew and mission operations people, the flight controllers, and we would say, well, this is what we need the crew to see. And we would draw a thing on a blackboard, and then we would take that and turn it into a prototype program, first in PowerPoint, and then actually with a program, and then we would put that in front of a crew, and they would tell you what they didn't like about it, and we would watch the crew work it, and we could see the mistakes they made, and then we would improve that. And what you see here is the result of 7 years of that improvement.
And so these sims that we've been doing is designed to help us kind of find out what things work and what things don't work. And
that's right, and using more and more of the cockpit together. So the big milestone that we've had this year is we've finally gotten so that we are working with the cockpit as a whole. And so you have two people working together and doing a complete phase of a mission. In other words, an ascent all the way to orbit, all the way up to the burns that you do in orbit to adjust your orbit or adjust your trajectory, and doing all those tasks, which involves using many different systems. And so we brought all those systems together with all the procedures to do that as an integrated cockpit evaluation. And so that's a great milestone. We did that for the first time in this medium fidelity mock-up this September, and that involved doing also our first look at ascents and also ascent aborts, where you have emergencies where you have to stop going into space and return to Earth.
Tell me what is next. What are the next steps in designing this, and when do we know when we have the control system?
Right, the next steps for this, we're doing another evaluation in a couple of months in February, which will put it all together with a lot of malfunctions. So we're really going to stress the crews and give them a lot of breaking things that we want to make sure that they can work multiple malfunctions at the same time, working in parallel, and that this arrangement of electronic procedures in the glass cockpit is up to that task. And then next year we will be working with Lockheed Martin to actually take these designs and turn them into the flight software that will actually be used by the crews going to Mars or the Moon or an asteroid.
This is so exciting. And so earlier we talked a little about the EFT-1, the first exploration flight test vehicle. It's not going to be a manned vehicle. However, will there be any data from that test at all that will help further development?
Absolutely, there will be data from EFT-1, and in fact we are setting up we will take the EFT-1 data as it happens and feed it into these displays so we can watch how the displays would look if you were on the EFT-1 spacecraft.
Well, thank you so much for taking the time to show this to us. It's all very exciting. You guys are doing obviously a great job, and we look forward to seeing what's next.
Thank you.
Thank you.